Okay, we're going to work on a few more topics here towards the end. Quadratic functions and their graphs. Okay, we've already worked with this thing here, this form, and we viewed it as a squaring function shifted k units vertically. Okay, now that squaring function, and even this one here, are two special cases of the more general form of quadratic function that looks like this. Now, what we're going to do is we're going to work with a few of these, look for some special characteristics that might be visualized in certain forms. In other words, when the equation's in a certain form, you might be able to tell what it does and what it looks like just by a few of the parameters within the equation. Okay, so first thing is, in general, when you have something like this in this form, this is the standard, or the well, it's the one of the forms, one of the special forms of the quadratic. Okay, general form, I could say. Now, if that number in the front, the a, if that is positive, we have an upward parabola that looks like this. Okay, and if it's negative, we have something that comes down like this. Positive comes up like that. Negative, it goes downward. So you can kind of think as up, like a cup up, looks like a cup sort of, and this one is down, looks like a frown, down frown. Okay, now, okay, so for this form here, we've already seen, and we can generalize, if k is positive, then it's a graph of a squaring function, k units upward. Okay, if it's less than 0, then it's k units downward. So with that in mind, we can easily graph things like this, because we know that it's a parabola. In other words, a parabola does this, the x squared. So ours is just going to be up 1, 2, 3, 4 units, and it'll do the same thing, like that. Minus 2 would be down here like this. Whoops. Let's go backwards on that. Okay, minus 2 is down here. What's it, 2 units down? And it comes up like so. Like that. Okay. All right. Next one. Okay, let's look at this. And let's try to zoom in a little bit on that so we can see a little better. Okay. Now, when the quadratic is in this form, we remember from some of the work that we've done with these, just kind of randomly graphing them. We know that this thing turns out to be a graph of x squared shifted to the right h units. When h is less than 0, then it's going to go left h units. Okay, x symmetry is the line x equals h. So let's take a look at that. Let's try it. The idea is to be able to graph these quickly without having to plot a whole mess of points. So this one here will be a squaring function, but it will be with its vertex at 3. So in other words, over here at 3, you will see that curve like that. And we can always put in a few more points if we need to, but overall, I just want you to be able to recognize, the shape of the graph and the basic structure. This one will be This is x minus a negative 4 like that. So we can see that you'll be over here at 4 units over, coming up like that. Okay. Likewise, this one, 2 units over, coming up like that. I'm roughing that in. This is a half unit to the right. So it comes in like that. And in each case, these do have axes of symmetry. Runs right through here, this one, right through there, right through there, and this one, whoops, that's the vertical line, x equals 1/2. Okay. Okay, now I don't know how much we missed since I've been watching here. What happened here? There it is. Okay. Uh-oh. I don't want that to happen. Okay, let's just throw that on here. See what we got here. Okay, so I'm just backtracking a little bit. I'm not sure if how much of this I was recording for you. Yeah. Okay, so we got that. Yeah, we got all that. This was the part that was giving me trouble. Okay, so let's see. Okay, so here's the summary now. Talked about that, and then we're working on this one here. Okay. All right. Well, we were working on it until the software kind of was giving me problems. Can't figure out why it's been doing that, but I'll think I know why. Okay, I think we'll be okay now. Okay, so now, let's see, we're here. I want to work with this, but we can't tell what everything is, so we're gonna do this. Uh-oh, it's doing it again. Why? Okay, I think we're back again. All right, now, I need to complete the square. I need to get it into this form up here. This is the form I need so I can identify all my pieces. Okay, so I'm going to try to complete the square on this then. So here, I'm going to have an x squared plus a 6x and a 3 squared. And subtract that same 3 squared. That way it's like it didn't happen, but now I can write this as x plus 3 quantity squared. And then this will be, well, it won't be a plus, will it? It will be minus 4. 5 minus 9. All right, so in this form, I can see everything. I can see my vertex. Okay, vertex would be a -3, -4. X symmetry. We've got an x equals -3. And it opens up, right? And we can put a nice little sketch together. -3, -4, 1, 2, 3, 1, 2, 3, 4. So about there. Each vertex opens up. Whoops. Okay, there's the symmetry axis. And it's just regular x squared type parabola. So from here, it'll come over 1, up 1, over 2, up 4. It's going to be here then. And then you'll have those same order pairs symmetric to the axis here. Coming in this way and like that. Okay. So we could mark those order pairs if we wanted to. Also, you can read them right off of the grid. Okay. So example 1. What we have here, I don't see anything. What happened to that page? All right, well, something went, something missing here. Well, let me double check something here. Okay, here we are. Now, I'm not going to go into the generalization of that routine that we just did on that last problem, but if you start with this form that we have here, start with that form. You can do a completing the square like we just did on that particular example, and you will arrive at this result here. You'll have your x coordinate for the vertex, be the first number, and the y coordinate will be this number. Okay, so again, you'd have to run through that whole process. I don't think it's worth our time right now to do that. We're just gonna work with this result here. And really, this is the most important thing to remember, because once you have this, you can always find this number. Okay, so let's focus on that as our problem now. So we're going to try to find the vertex of each of these without putting it into this form. I don't want to spend the time on this if I don't have to. That's the idea. I mean, I could, but this is a lot faster actually. So here's how it works. The x coordinate for the vertex. So we can say x sub v for vertex. It's going to be minus b over 2a. And this problem, that is a 4 over 2, which is a 2. So the x coordinate is a 2. What's the y coordinate? Well, I'll just put it in here. I have a 2 squared minus 8 plus 5. So we got 9 minus 8 is a 1. So there's our vertex, 2, 1. Okay, that's it. So you got a quick way to find the vertex. Now that you know the vertex, you know what happens to the axis of symmetry. It runs right through the vertex, and you know you can find a couple easy points right from that vertex based on the shape of this. There's a 1 in the front here. So it's you're just about there once you've got that vertex. Okay, so for this one, x for the vertex would be minus b over 2a again. So you'll have to remember that. And that's a minus 3 over 4. Okay, now this one's a little bit troublesome just because the fraction, right? It's going to be 2 times negative 3/4 squared plus 3 times negative 3/4 minus 1. So I get, what is that? 2 times 9 is 18 over 16, right? And then minus 9 over 4 and minus 1. So this is all the work in the problem right here, this arithmetic. So that's, let's see, 2, 9, 8, right? And then it looks like this will have to be 8 over 8. So we got a lot of work here. It's 9 minus 18 minus 8 over 8 is, let's see, negative 9, negative 17 over 8. Looks like. Okay, so all of that was just to get this coordinate. We spent a lot of time in that one. Okay, but there it is. Okay, now next one. Over here. Again, xv is minus b over 2a. So just take your minus 5 over 2 times 3, so it's minus 5 over 6. To get the y coordinate, you'll have to find this value, f of negative 5/6. So you're going to have a 3 times a negative 5 over 6 squared plus 5, negative 5 over 6. Again, we're going to work hard for this one because of that fraction. And so this one will be 3 times 25 over 36 minus 25 over 6 plus a 2. So we're going to have 25 over 6. Oh, wait, that's a 36. That's funny. I was canceling that 3 with that 3 there. Not quite. That's a. Yeah, it's going to be a 12 down there. 3 over 36 is 1 over 12. Minus, let's fix this one up. This will be 50 over 12. And this will be 24 over 12. So that'll be negative 25 plus 24 is negative 1. So there's your vertex. Negative 5 over 6 with a negative 1/12. Okay, so a lot of work, but and you might have been able to complete the square on this and put it into this form up here faster than what we just did. I don't know, maybe you would have. I think it'd probably be a wash on that one. Okay, this one. We need to get it into that form. So let's write it this way. First of all, 4 is an x squared plus 5/4 x. And then it's like that. Okay, 4. Gotta complete the square on this thing. Wait a minute. I take that back. I was going in the wrong direction on that. Let's undo that for a sec. I was going to complete the square on that, but there's no need for that. Okay, so we just wanted to do our vertex. Minus b over 2a. Okay, so minus 5 over 2 times 4 is 8. Okay, so there's the x coordinate for the vertex, and then you want the y coordinate. You just calculate f of negative 5/8. So you have 4 times, it would be a 25 over 64. And then minus 25 over 8. So I speed it up a little bit there. That's 25 over 16 minus 50 over 16 is minus 25 over 16. So your vertex would have to be negative 5/8 and a negative 25 over 16. Okay. So that's the idea. You're going to use that minus b over 2a. That is going to help you to find those the vertex for those parabolas. Okay, let's see what else we got here. Okay, here's an application problem. This one, it's kind of an interesting problem. You can get a little bit of context here. Here's your function. Notice it is it's a quadratic. It's what we see. And it says the ball is tossed and the height is given by this function. Find the maximum height of the ball and the number of seconds it takes the ball to reach the maximum height. So what we're looking for is the vertex, okay? We're looking for the vertex. If this is how the height is graphed, then that's how we can find the maximum height. So find the vertex. Well, minus b over 2a. So this will be t. And according to our formula here, we have a minus 24 over 2 times negative 16. So we've got what, 8 times 3 and 4 times 8. So we got a 3/4 there. Okay, so 3/4 is the t value. And find the maximum height of the ball and the number of seconds it takes for the ball to reach the maximum height. Well, this is the number of seconds. This gives us the number of seconds it takes to reach that. Now, if you want the actual height, we have to compute h of 3/4. This will give us the height. So in other words, you got the height measured this way, t this way, and at 3/4, you have your axis and you have that vertex up there. Okay. Now this isn't the path of the ball. This is just a graph of height versus time. Okay. It's not a graph of the path of the ball. Sometimes students erroneously think that's the direction the ball's falling or whatever. Okay, so in here then, you're going to take that 3/4 and we'll put it into here. So we have minus 16, we have a 9 over 16, and then plus 24 times 3/4. So this one will be a negative 9. And this one will be plus, let's see, 6, 3 is 18. So we got a 9 there. So the maximum height is 9. And it occurs in 3/4 of a second. So let's see. Let's try it next one now. I think there's one more problem here, maybe 1 or 2. Let's find the vertex, the direction it opens, and any intercepts. Okay, provide a sketch with at least 3 points. Okay, so let's go at this one. Okay, let's get the vertex first. Okay, x of b minus b over 2a. So that's a negative 2 over 2, which is a negative 1. Okay, let's calculate f of negative 1. It's going to be a 1 minus 2 minus 3, which is minus 4. So there's our vertex. Negative 1 negative 4. So negative 1, 1, 2, 3, 4, right there. Stay. There it is. Okay, and opens up. Okay, opens up. We got our axis of symmetry runs through here. And for intercepts in this case, well, guess what? Intercepts they occur when this thing equals 0. So that's when the height of the graph is a 0, when it crosses the x-axis in here. So that's what we want to try and find. In other words, where does it cross anywhere in here? Does it cross at all? We can find that by setting it equal to 0 and solving. So now I have to solve this. X squared plus 2x plus minus 3 equals 0. Well, that's an x plus 3 minus times x minus 1. That gives us a negative 3 and a 1. So we're over here at negative 3 as a cross point and at 1 as a cross point. Okay, and notice that is symmetric to the axis here. We've got 1 on each side. Both of them are 2 units away. That's what we would expect. So that's enough to get a decent graph. If I could just draw it. I don't know why it's so hard to draw with this thing. Let's see. Get rid of that. Let's try it again. So I know it's going to cross there. Okay, pretty good. There. Okay, you know what? That's not all that great. Let's try it again. Crossing right there. And in here. Okay, so that's, well, again, a little bit sloppy, but there's one right there, and there's another one over here. It's negative 3, 0. Okay, and our vertex down here at negative 1, negative 4. Okay, so notice on that problem, we never did worry about this whole form. We didn't go that route. We used our minus b over 2a form. We used the fact that we know it opens up. We found a couple intercepts to get our graph. Okay, so that was a quick way of doing it. Another thing is that this thing, when x is 0, this will cross at negative 3. So technically, it is crosses right there. My graph's really kind of sloppy. I can't draw with this device. It's really hard. I'm lucky I can get what I got here. So, all right, let's move on then. Let's see what's on the next page here. Okay, so this is just a few more examples is all it is. I won't do all these. I think you guys have seen enough of this. It's time you just get into your homework. And move on. I'll tell you what, I'll do find the vertex of these if you're into it. Minus b is a minus 4 over 2a. That's a negative 1, so that's a negative 2. That makes a 2, so the x coordinate is 2, and the y coordinate for that vertex would be negative 4 plus 8 minus 4 coming off of here. That makes a 0. Okay, so 2, 0. All right, let's do that next one. Okay, well, you can see this is just a parabola that's been shifted down 4 units. The vertex is obviously 0, -4. But if you weren't watching that, you could say, hey, it's minus b over 2a. Well, the b is not in here. There's no b. You've got a is 1 and c is -4. B is the x term. It's missing. That means it's a 0. So put a 0 in here, you get -4. There's your vertex. Okay, so don't be thrown by that. This one's going to be a little more work. Minus b over 2a. That would make a 1 over 4. And then h of 1/4, you'll have to figure that out. That gives 2 times 1 over 16 minus 1/4 minus 3. So this is 1/8 minus 2/8 minus 24/8. So that becomes what? Minus 25 over 8. And that's your vertex. 1/4 and a minus 25 over 8. Okay, now, so you guys can put the rest of it together and be easier for you than me. But it's hard for me to get these points on here and make it look neat. It bothers me. Okay, so that's it for now. That's enough. That's long enough.